Hi, we present Hyperedge attention networks, HEAT, a generalization of transformer that learns to represent typed and qualified hypergraphs. What do we mean by typed and qualified? Hypergraphs are made of hyperedges. Traditionally, each hyperedge is a set of nodes. However, this is restrictive. Instead, we consider that each hyperedge has a type and each node's participation in the hyperedge is qualified. Each hyperedge can also be thought as a predicate, like the one shown at the bottom. We look into two domains that can be represented as typed and qualified hypergraphs. First, knowledge bases can be represented as typed and qualified hypergraphs, allowing for richer information to be represented. For example, whereas commonly a knowledge graph would have an edge between a person and the major they studied in the university, a hyperedge can augment this with additional information, such as the institution where the studies happened, or cover special cases, such as double majoring. We also present a nodal representation of source code. We can represent code as a hypergraph, and hyperedges being the sequence of tokens, the syntax nodes, data and control flow, and even arbitrary functions. This representation is more compact and expressive than traditional graph structure representations of code. To process typed and qualified hypergraphs, we devise a neural architecture we call HEAT. HEAT follows a message-passing neural network paradigm, where node states are updated in each layer, propagating information through hyperedges. HEAT first computed messages through hyperedges. Each node and hyperedge has a state. Then, we add learned positional encodings represent the qualifier of each node participating in the hyperedge. Then, multi-head attention does an all-to-all exchange of information. This yields messages back to nodes and a hyperedge state update. These messages are the analogs of messages in graph neural networks. All messages have been computed, we need to update the node and hyperedge states. To achieve this, all incoming messages are aggregated with a permutation invariant function, and the state updates are computed using the transformer update network on the right. So to summarize, HEAT processes typed and qualified hypergraphs. Each layer uses multi-head attention to compute information through hyperedges and the standard transformer update to update node states. This can be repeated for multiple layers. But now imagine that if we have a degenerate hypergraph with a single hyperedge, tokens and positions as their qualifiers. By construction, HEAT reduces to a standard transformer encoder with a minor difference that learned positional encodings are added to each layer. For more information and an evaluation of HEAT on the two domains I discussed, please take a look at our paper. Thanks for watching.